everybody, I'm Mary.
And I'm Shantel.
And today we're going to explain Newton's second law.
The second law states that the acceleration of an object is dependent upon two variables, the net force acting upon the object and the mass of the object.
English, please?
It means that an object's acceleration is determined by how strong the force is making it move and how much the mass has in the object.
Okay, I see. It's kind of hard to process all of that, though.
Here, let's have our experiment experts, Eduardo and Andrew, give an example.
Thanks, Shantel. Hey, everybody. My name's Andrew, and this is my assistant, Eduardo.
Actually, Andrew, you're my assistant.
Anyway, we're going to give you guys an example on how the net force of an object and the object's mass affects the object's acceleration,
Which is Newton's second law. Now you can actually test this law with any two objects that are moving. Today we'll be using a quarter and a piece of paper.
Since these objects have very different masses, you can assume which one will accelerate faster. Eduardo, which do you think will accelerate, or fall, in this case, faster?
Well, since the quarter has more mass, it can be assumed that it will fall quicker.
I guess the only way to figure out if you're right is to test it. Here we have a tub of water. We're going to drop our objects into the water and see which one accelerates quicker.
Wait, but what force does the object have if we just drop it?
Get ready. It is the force of gravity.
Did you see that? I was right.
And so was science. Let's share our results with Shantel and Mary.
Wait, isn't the object with the smaller mass supposed to accelerate quicker?
Yes, but you see, they used gravity as their net force, so the quarter went quicker.
But why is that?
It's because the quarter weighs more. Weight is different from mass because weight is actually the force of gravity on the object. You can find it by multiplying the mass by the acceleration of gravity, which is 9.8 meters per second squared.
Oh, I see, but why did the paper fall so slowly?
It's a glorious thing on Earth that we have called air resistance. The more surface area an object has, the more air resistance it has. Since the paper didn't have as much mass, it has more air resistance, but that's a whole new topic in itself.
So what if we didn't get into all that fancy air resistance? Would an object with the smaller mass accelerate quicker?
Yes, let me show you. If I use the force of my fist to hit this book, you'll see that the car without the weight accelerated quicker. But if I were to use less force, the object's acceleration would change. See, with less net force, the objects accelerate slower.
That's Newton's second law. The mass and net force of an object affects an object's acceleration.
Exactly.
We also learned about gravity, that has a force of 9.8 meters per second squared.
Yes, we did. Well, that's all for today on Science in Slow Motion. See you next time.
Bye.
See ya!